Hello guys, good evening. I hope I'm pretty much audible as well as visible. So I welcome you all again in our today's session. So today, as per the planned structure, we will be taking care of the NumPy sessions. So NumPy, we have been discussing about NumPy over some time back. So that was part of our advanced Python scripting. So NumPy is again one of the packages which we're discussing about for your data analysis purposes for taking care of the arrays specifically. So we discuss about a lot of functionalities available under NumPy, right? So what we do is we're gonna just do a quick recap of NumPy because it's been some time we discuss on that. So and then we take some of the remaining very important functionalities available under NumPy, which could be useful for your data analysis part. So it's again one of the very good high-level API available for your data science analysis work. So we'll be discussing about that. But again, anybody has any questions in anything whatsoever we have discussed so far, please feel free to put out your question so we can take it as it comes. Right. So again, guys, if anybody has any question, do let me know that. Cool. Right, as per our agenda, so we will be talking about NumPy and we'll be doing a quick recap of NumPy in today's lesson. But before that, let's have a quick round of introduction as always. So my name is Arpit Jain, and I'm a senior data scientist myself, and I've been into industry for almost 9 years now. Along with that, I'm also a motivational speaker, so I talk to students regarding their career. I take the career mentorships and all that. So that's again I do along with my work. So as part of our subjects, we'll be talking about Python SQL data science. So Python we already started about 3 months back. That's what advanced Python scripting is. So that's what our agenda is towards the Python part. So we'll be talking about that. Along with that, we have SQL and data science also running parallelly. So and then we have the classes on and off based on all of these individual subjects. So that's what we do. From the code perspective, guys, so we have this code which is Python 10, and so you remember, so Python 10 is the code exclusively available for you for to getting a free sample Relevel test paper, right? So you know this by default. So what exactly Relevel is? So time for a quick promotion, guys. Please bear with me for this. So many times the candidates do miss out on the great opportunities due to multiple reasons. So it could be like they don't have a better degree or might be a poor networking. And also the resumes is not standing out. So there are at least 100 other applicants for your job, for the job you're applying for, right? And there could be some issues with your resume not having the right keywords, or could be some other issues which is beyond your control. Could be a potential reason for you to miss out on those opportunities. And also you're applying for a number of jobs, and but still you're not getting even a single interview call. So very practical issues, guys, that happens. So to cater these problems only, Unacademy has launched Relevel as the platform, which is India's first test hiring platform, and it is helping you to get your dream job. And how exactly it's done? So it's basically like you're dependent here for the job based on your skills and talent. Okay, so you're purely dependent on your skills and talent. Yeah, and it's not at all based on any sort of degree or any networking, right? So it's purely on your skills and talent. So how it works? So it's more of an assessment platform. So where you will be asked to go through a test, right? So test would be on the area of your interest. So there are multiple platforms, multiple development tests. So depending on your area of interest, you can choose the test which you want to be part of. And then the only expectation here from you would be to get the best score out of this test. That's it. So and based on that score, you'll be approached by the companies, right? So that's how it works. There are certain other benefits also involved if you participate in the Relevel testing platform. Like at least there are 50 plus companies, including the top startups and even the unicorns, are having the direct tie-ups from the Relevel platform, right? So and the companies include Urban Company, Ernst and Young, Cred, Upgrad, many more, right? So You can just, the list is ongoing. So these companies, they have the types from Relevel and they hire directly from this platform, right? And also at least 1,000 plus open job positions right now across different developments. So business, front end and the back end developments, multiple roles also available under these portfolios. This is completely online, so you can take this test from the comfort of your home, right? So you're not supposed to be physically present anywhere for this. Also, this is completely, I would say, free. So you're not paying even a single penny to attempt this test. So you can take this completely free. The only expectation here is like you have to, as there are multiple rounds of the assessment, so you have to finish the entire test in a single day. So you have to finish all the rounds in a single day's time. So that's the only expectation, and that day could be of your choice. And the score would be revealed within a week. So after you have given the test. Unfortunately, if you're not, if you feel that you have not got the good score and all that, so you can reattempt the test again, but that can happen only after 30 days from the first day of attempt, right? So that's one thing. Also, it's a minimum qualifying criteria. So right now it's 70%, so you have to score 70% of the total marks. So right now I think it's for 1,000. So 700 is a bare qualifying score to make your Relevel profile. Anything on top of that will be cherry on the cake, right? Also, there are some exciting goodies, rewards involved here. So if you are one of the top scorers in a particular category in a month, you will be rewarded with some goodies like MacBook, iPhone, and something like that. So that's again an exciting thing. So with this, guys, you are in a unique position basically to invite interest from the companies instead of you hunting for your own opportunities. So it's like once you've given the test, you can just sit back and relax and wait for your approach by the company. So once the scores are revealed, right? So you'll be contacted based on a score by the companies itself. Again, registration is also quite easy. So you have the link available in the description, so you can just go through that link. The first thing they will ask you to choose the test of your choice, like business development, front end and the back end development, multiple roles also available, like sales associate, customer engagement associate in business development, Angular web developer in front end, back end engineer, data engineer in back end development. So depending on your area of interest, you can choose the test of your choice. Then the next would be to choose the date of your choice, right? So as the slots are limited, it's a beta platform. I would request you to choose select it fast. Right, so once that is done, the last is fill up your demographics in the admit card, like full name, email ID, birth year, current state, and gender. Along with that, you have a promo code option. So you can use the code Python 10 here. If you use the code Python 10, you're going to unlock a bonus sample test paper. Right, so you'll be unlocking a bonus sample test paper. This is nothing but a replica of the questions which you'll be expecting in the real test. So that's more of that sort, right? So and then you can create your account. And here on our account, you can see a tab, which is practice tab. So once you go in that tab, you will be able to see the sample test paper, which you have unlocked by using the promo code, right? Python 10. So once that, so please practice it before your actual test. So, and then do give your best for the examination. So do register for it, guys. So at least since there's no cost involved anyway, so there's no loss for you, right? So you can at least try it for once. And if you feel that somehow you're not getting benefited, you can definitely take your decision henceforth. Right, so along with that, guys, also we have an official Telegram channel, so do join that. So it's a one place stop for you for all your queries, so please join that. All the upcoming schedules and all will be getting here. So, and as always, please do like the video if you feel that you're getting benefited. Do like and subscribe, so, and then share with your friends. With this, we are into a content slide, guys. So as described, so we are into our advanced Python scripting session, and then we are going to do a Numpy recap. So we did discuss about Numpy functionalities a lot in the past. So we're going to do a refresher of some of the good functionalities available in Numpy, and then we're going to be talking about the rest of the remaining functionalities available. Anybody has any questions anywhere, please put up your question in the chat. Okay, so with this, let's proceed. I hope my screen is very much visible. So NumPy, so what is NumPy basically? So NumPy is like just another Python package, okay? Stands for numerical Python. is the numerical Python library which contains the array processing. So what are arrays, right? So arrays is again another data type which can hold a single data type. For example, it can have an arrays of numbers. It can have arrays of array of numbers or array of strings. So it only contains a single data type. Okay, so that's the whole objective of arrays. Why arrays? So arrays processing are comparatively faster, and it's purely technically it's for my NumPy numbers calculation. So, but again, it depends on the usage again. So NumPy arrays are comparatively it gives you more flexibility in terms of numbers. So the standard numerical functionalities available in Python is a bit limited. So, but NumPy gives you a lot of flexibility, a lot of options available to play around with the data in form of arrays, right? So that's how, and the base of everything here in NumPy is arrays. So all the computation is happening basically on arrays, right? So that's basically a NumPy is. We have already seen that. Installation is quite easy. So broadly, there are three major concepts in arrays. Okay. What are those? The first is ND array. So basically the n-dimensional array. So collection of same type of information, right? So collection of same type of information is a more of a collection data. So that is my ND array, n-dimensional array. The second is my D type. So every item in every singular item in my ND array is nothing but a D type, right? And once we take out this D type out of my ND array, so it's like a singular object right now. So that's the scalar object, right? So array scalar, right? So these are the three basic concepts, very important basic concepts of my NumPy array. So ND array is nothing but my whole collection of my points in form of an array. So that's my ND array, n-dimensional array. D type, every individual element of my ND array is called as D type basically. Array scalar, if you take out that, if you slice out that particular element out of my ND array, that is called as array scalar. Okay, so three concepts, very important. Cool. So how you initiate your array? So very basic functionalities. We've already seen that np.array. So if you call array function, you're going to initiate your array, right? And there are multiple good functions available here. Broadly 6. So object, D type, order, sub OK, and endim, right? So object मैंने आपको बताया basically your array type object which you're gonna pass. So the data which you want to be converted into an array. So you can directly call an array function on top of that data object. So that's how you're going to convert that object into an array object, right? So you're going to pass it here in object. D type, basically data type of the object. So what data type you want to be, you want this data to be part of, like maybe int, and then int maybe you have multiple options like int 32, int 64, like what memory you want to choose. Because as I said, right, so NumPy arrays are faster. So how exactly it is faster? It has an option of memory optimization, right? So if we know that what exactly data has to be part of my array, for example, say I have to store say age of a people, right? So we know that age can only lie between 0 to 100. It won't exceed maybe 120 max, right? So it cannot exceed more than 150 by in that sense, right? It cannot exceed more than that. So I know that the range is only 0 to 150. So why to have a data type which utilizes a memory of say storing a data which can store up to 1 crore numbers, right? So not required. So I need a very small memory space which is required to store the number between 0 to 150. That's the max I want, right? So I would choose the very minimum base of my ints, like small tiny int. So I have something called as tiny int. So all of this, so I'll talk about the data types available here. So basically, in your NumPy gives you a flexibility to choose the data type even in the like int, float, and all that, exact memory wise, right? So it gives you the so it does not waste out any memory. So if the memory is smaller, so indexes will be smaller, right? So accessing the data will be faster. So that is the reason why, based on this optimization, NumPy arrays actually does work out fast. So it eases out and it kind of fastens my processing speed. So that's how, again, one of the ways. But again, arrays generally are faster. So, but again, to define it, so object, D type, order. So order, again, very important. Look at this, guys. So we have 3 types of ordering, right? So so it's like how you're going to fill up the information, right? So we have C, F, and K. So C is nothing but my row major, okay? So C, like if I'm giving C as my information, so you can see this, the arrow. So first, when we fill up the data, so firstly, the first row would be filled. So A11, A12, A13. You can see the top row is filled. And then once that is done, so then it comes to the second row. Then it comes to the third row, right? But if we give order as F type, like Fortran type, so here it's a column major. So don't get confused, C with column, C is row major, so that's the inverse here. F is Fortran type, so F is like column major, okay? And now in the column major, you can see this. First, the data will be filled like this: A11, A21, A31. So first element of all of my individual rows, then the second column, and then the third column, right? Sub OK means like if I'm passing a subclass, so this has to be true, right? So if I'm passing true to the sub OK, that means that, for example, inside an array, I'm passing a matrix, right? So here the data would be identified like, okay, now matrix also identifies it as an individual data type. So it won't be merged with the array data type, right? So that's how sub OK means. So in the inner subclasses are also given the parity respectively. So that's where true means here, right? Ndim means dimension of my resultant array. So in what is the dimension I'm expecting from the resultant array. So we can have the dimensionality also defined here. So just look at some examples. So now for example, suppose if I give say this, so it's just a one-dimensional array. So I'm passing one-dimensional data here. You can see this, just a single bracket, right? So single bracket enclosed, 1, 2, 3. So if I just print, I could see 1, 2, 3 here. So the only difference the way array looks like is we have commas. So this is my list of elements, right? So list of 1, 2, 3 separated by commas. But in arrays there is no commas. You can see this. So 1, 2, 3 is given just by separations, one tab, right? So that's one space character. So that is nothing but your arrays, right? So without commas. So that's how it looks like. Two-dimensional arrays. So more than one dimension basically. So now I'm passing two different elements. So you have 1, 2 as first element and 3, 4 as the second element, right? So now again this has been converted into two-dimensional array. So you have 1, 2 as first element and then 3, 4 as the second element and part of my same single ND array. So this entire thing is my ND array now, and this 1, 2 is my data, so D type, so I mean it's like one single element, and this is my another element of my ND array, right? So now here also can you see this? So for example, suppose I'm passing this one-dimensional data. So this is a one-dimensional data, so one-dimensional is 1, 2, 3, 4, 5. But in case I pass ndim as 2, so it's like I'm defining that although it's a one-dimensional data, but at the end I want this to be classified as a two-dimensional data. So the dimension, the output dimension of my array should be 2. So can you see this? Now I have two brackets evolved here. So now even the one data is converted to the 2D data. So that's how we can define the dimensions here, usage of that. So data type, I can define a data type. I can give complex, int, whatever I want. So this end converted data would be of that data type. Okay. Sub OK I was talking about. It's an interesting argument. So sub OK means that I'm using the subclass of my past information. So for example, suppose this. Look at this. So I have like this. So this np.array, I'm passing a matrix. So basically internally also there is one data type, right? So it's another class of my data. So it's like np.matrix. So the output is not an array, output is a matrix. So that's what sub OK true means, right? So just look at this now. And if I do the same thing np.matrix as sub OK as false, so that means that the output is in the array format. It is not identifying this as an individual subclass, okay? So it is taking the outer major class as an output. So the output is an array data. But if you give sub OK as 2, that means that I'm giving priority to my inner subclass also. So that's where the output is the matrix data type. So that's again a very interesting argument available here, guys. So do not get confused by that, right? So I was talking about the data types, right? So remember, so in data types we have multiple options. So instead, so technically it's only 4. So Boolean is by default. So int, float, and complex. Okay, so only because it's again a numerical type of data, right? So I have majorly 4 different types of information. So int, float, bool, int, float, and complex. But individually, you can see a lot of internal available data types available, like int 8, int 16, int 32, int 64, right? So you can see this. So this int 8 means there's a range given here, right? So you can see the byte range of -128 to 127, right? So basically, if my values is expected between this range, -128 to 127, I'm going to use int 8. Okay, so it cannot store any value which is beyond 127 on the upper side and -128 on the lower side, right? So is the smallest memory available in your data type for int, right? Likewise, for all of these numbers, I have the specified ranges given here, right? So this is the range of data it can handle, it can store. Cool. Likewise, we have something called as uint, so unsigned integer, right? So unsigned integer means here you can see this, it is taking both the negative and the positive values, right? but the unsigned integers are only taking the positive values. So you cannot store the negative values here. So it ranges from minus 128 to 127. Just add this up, modulus. You can see the range is 0 to 255 now, right? Just the addition of my bytes here, so 256 bytes basically. So it's like 0 to 255 is my number of bytes I can, number of the data data I can store in this unsigned integer. So that's the range of my data, right? So likewise, starting from 0 for multiple numbers, 16, 32, 64 and all that. So likewise, for the float, I have this 5 bits of exponent and 10 bits of mantissa. Likewise, for all of this, my different float values. Likewise, for complex as well. So basically, so the numbers here is representing the amount of storage I would be needing to store the data, to do the values of my data, right? So that's basically what it is. And once you know the range which you're storing into, you can properly optimize your memory. So suppose what is the need of having int 64 when you're storing just the age, right? You will not be having this much of range. I mean, technically it is impossible, right? So why to waste memory? So you can have this. Instead of using int 64 for your age, you can use int 8 for your age, right? So likewise, depending on the number, depending on the data, you can choose the data type. So that's the flexibility you have in NumPy. You don't have it in the standard Python or library. Cool. Any question in this too, let me know. So that's the data type for your NumPy. That's where we have a very great advantage. It gives you a lot of variety compared to the Python standard libraries. Cool. So right, so now we talked about the ND array, just like giving the random data here. So that's what we have defined it. Now let's try to see a specific individual examples, right? So let's try to see more specific examples defining the data types of it, right? So for example, now I've created a data. So you can see this, I have defined a data type information, which is a NumPy int 64. So I've just created this DT as my the data type, okay? So now I'm making a one-dimension data where I have the age column, and age column is mapped with my np.int8. So I talked about int8, right? So int8 for age. So that's a very standard thing, right? So basically now here I want, so in the DT basically, so DT is like it's mapped with one of the column. So by default, whatever data I'll be passing, I'm naming that column. So I'll be naming it as age, for example here, and I'm giving the data type to it, which is np.int8, right? So now let's create the information, right? So let's create the information. So now, for example, if I just omit this for now, and now if you're gonna pass this, so I'm creating an array information. So here in array I'm passing a 1D data, and in 1D data I'm passing 10, 20, 30 basically, right? And I'm passing the D type as DT. So basically now here I'm passing D type as this age and int8, right? So now like just look at this. For example, I'm just gonna omit this for now. So now NP is not defined, my bad, I have not run this, just a minute. And put NumPy as NP. So this is what your information is. And now if you're gonna run this, sorry, my bad, DT मैंने define नहीं कर रहा है. Cool. So now you have this information. So now 10, 20, 30 mein by default you are giving data type as int8, and also you are giving the name to this column. So now if you're passing this data has no name, right? It is when we are passing this object, we are not giving any name to this data, but by default in this data type dt, I'm also specifying the name age. So if I have to call this information, I have to again print a particular like indexing my information. I can call it in the form of a name also. So I can just pass, instead of this, I can pass this age. So if I do this, I can also see the exact array available under age. So this is my age information, right? So 10, my first element. So you can see this here. So I'm coming 10 comma 10 comma 20 comma. This is my information, right? So basically the first element is 10. So 10 is the age. So which is my element, exact element of my data type. So here 10, 20, 30 is what I'm calling on. So I can rename it also. I can give any name. So for example, I'm giving say number here. So I have to call it form of a number. So I'm naming this particular data giving this as a name. So that's what it is, right? So again, can be possible in NumPy array. Cool. I can make it complex. I can make it multi-dimension also. So here I'm just only passing age, so one dimension data. So one single data I'm passing. I can make it multi-dimension also. Like, so I can have a name, I can have an age, and also I have a marks column, right? So here we can see this with the name I'm passing S20, so strings of 20 up to 20 characters. In age means I8, so int 8 I'm passing for age. Marks again respectively float. So here you can see this is my entire data type. So this I'm defining as my data type. And now here I'm passing the data. So you can see this, I'm passing 3 elements now. Instead of passing one single element, I'm passing 3 elements, because in the data type I'm passing student, which is nothing but a multi-dimensional data type, right? So also individual names are given to the elements also. So technically this first is what? Name of my student is coming from here. This is my name. The second is 21, so nothing but this is my age. The third is 50, so basically this is my marks. So now if I have to call anything, so for example, you have to call say name, right? So this is my array, right? So array, if I'm calling name, so that's what? So my bad, right? So if I call name here, you can see this by default I'll be getting ABC and XYZ, and then likewise I can also have say age, so I'll be getting the age of my my entry, so it's 21 and 18 in form of arrays. So likewise you can also do it a manual check, so you can just keep on calling your multi-dimensional data and then you can have the exact values for them. Cool. So with this, we are into some interesting attributes available for arrays, right? So we discuss about a lot of things. So shape, reshape, endim, item size, empty zeros, ones almost similar, as array, from, iter, arrange, line space, log space. So we discuss about a lot of things. Just a quick recap again. Shape, reshape again. So these are nothing but to define the shape of my arrays, right? So what is the shape? So shape is nothing but my technically rows and columns, right? So number of rows and number of columns, the dimensions of my arrays, right? So like the way we have it for data frames also, right? So data frames with number of rows and number of columns हम निकालते हैं. So here is nothing but my dimensions of my shape. Shape is nothing but again the dimension of my arrays. That's what it is. If I have some form of a data, I can reshape. So reshape is nothing but it will be reshaping my data. So if I have say 2 cross 3, I can give it 3 cross 2, 3. It will make reshape as 3 cross 2 ka array. So whatever it is possible. So now let's take it one by one. So shape is again called by this function shape by default. So for example, I have this. So I've created 2-dimensional data here, right? So I have 2-dimensional data. So the first element is 1, 2, 3. And the second element is 4, 5, 6. I'm giving a 2-dimensional data here. So definitely it's a 2-dimensional. It's a 2D information. The first is the dimension. So if we pass the shape here, the first element of this is the number of elements it has, the array, the number of elements array has. Okay, so at the outer element. So here technically it has 2 elements, right? So two outer lists, 1, 2, 3 and 4, 5, 6, right? And the second element of my shape is nothing but my individual array ka element. So the sub elements of my internal individual element. So I have 3 elements inside my every single outer element of my array. So the second dimension data, the first dimension has 2 elements. The second dimension has 3 elements per dimension. Right? So that's what it says. So I have the dimension here is shape here is 2 cross 3 or 2 comma 3. So that's what it is, right? So that's the shape. So by default I have this. So I can also do the reshaping. So I can also specify what shape I want from the arrays. So for example, here is 2 cross 3, right? I can also give like 1 cross 6, for example. So instead of having 2 dimension with 3 elements each per dimension, I want this shape to be given as 1 dimension with 6 elements in that. So I can have it, right? So if I do that, we can actually do it. So now you can see this, the 2D array has now been, so this 2 individual elements are now being converted into 1 single element. So where this element has 6 one element of my ND, first element of my ND array has 6 elements in it, 6 sub elements. Cool. So you're basically reshaping your data with this particular thing. But instead of passing it like this, that h.shape is equal to a particular dimension, I can also call the function .reshape. So reshape is exactly does the same thing. So here I'm passing this a.shape is equal to 1, 6, right? So I can call a.reshape and call it, save it in some other variable. If I call it, it'll give you the exact same result. So a.reshape or giving a.shape is equal to some extra dimension. That's how it is. Cool. So that's the functionality here, guys. Coming back to my endim. So ndim भी मैंने आपको बताया, ndim is nothing but your number of dimensions for my information, right? So here I'm talking about my number of different elements I have, right? So here I have in the first case I have two elements, so like two different elements, as you can see 1 2 3 and 4 5 6. And in the second I have my one we reshaped it to 1 comma 6, right? So that's so in that case I have one dimension, so dimension is 1. So dimension means the number of sub elements I have. Cool. Any questions, guys? Okay, so I think I have one question. So it says, what is the difference between arrays and matrix? Okay, okay, a good question. So technically देखो मैं क्या बताता हूँ, इसमें multiple differences हैं. So if I मैं आपको कैसे, so arrays basically समझो कि ये आपका numpy arrays का data type है जिसमें आप single data को store करते हो technically. एंड मैट्रिक्स कंप्यूटेशन आपको क्या है वो डॉट प्रोडक्ट्स वगैरह में यूज होता है. आपको मैं इसका टेक्निकल डिफरेंस एग्जैक्टली, लेट मी जस्ट मे बी जस्ट शो इट यू इन दिस हाउ एग्जैक्टली यू कैन डू इट अप. जस्ट गिव मी अ मिनट. ओके, सो देखो अभी अगर मैं आपको बेसिक इंग्लिश में पहले समझाता हूँ क्या होता है. अरे क्या है, जैसे आपको ने बताया, इट्स अ होमोजेनियस कलेक्शन. सो इसमें वी कैन ओनली हैव अ सिंगल डेटा टाइप. ओके, सो इट्स लाइक n dimensional का डेटा हो सकता है, so it can be under 2D or 3D, so multiple dimension, but all the data can have a single data type. So that's the prime objective of my arrays, right? But matrix का simple आप समझो rows and columns है, so it's like another table for you, right? A simple rows and column thing, right? एंड इसमें मेजरली आपका डायमेंशन का भी डिफरेंस है. सो डायमेंशन लाइक मैट्रिक्स कैन हैव टू डायमेंशन, सो इट कैन हैव, इट्स अ बेसिक सिंपल रो कॉलम थिंग. सो टेबल, जनरली टेबल जो आप देखते हो, इट्स लाइक अ मैट्रिक्स, अनदर मैट्रिक्स फॉर यू. But in the arrays, you can have multiple dimensions. So you can spread it into 2D, 3D, 4D like that. So that's, I think these two are the, I would say, technical, I would say, differences. But इसका यूजेज में अगर आप मुझसे पूछोगे तो arrays more towards your mathematical computations में यूज होता है. Matrix is not, I think that matrix nothing but just another rows and columns, right? So another rows and columns of information in a 2D plane. So that's like that. So but arrays is more towards advanced computation of your numbers. So that's towards your NumPy part, right? So that's, and it's homogeneous. So in arrays it's more of a row column ka thing. Cool. So I hope I answered your question. But still, if you have doubt, do let me know that. And again, guys, I'm unwell today, so if my voice is unclear, do let me know that. I'm trying to be loud as much as possible, but I have a slight bad throat. So do let me know if I'm inaudible by any chance. So I'll try to repeat it. Cool. So that's about ndim. It's pretty much fine. So I think ndim is just like giving you the dimension of my data. So nothing more than that. Cool. So item size again. So item size is again a very good thing. So it gives you, it returns the element of arrays in bytes. So basically the byte memory, it is that particular data type is storing, it is returning you that. So I would say the bytes. So the element in form of a bytes. For example, np dot. So the int 8 generally by default takes 1 byte information. So it's like 1 byte of data, right? So and float 32 is taking 4 bytes of information, right? So if we just do it like print dot item size like the amount of memory it is holding in your for the computation purpose. So it's like more of a byte storage information it has, right? So that's what it returns, the item size. Again, you can definitely optimize this. So now based on the data which you are storing, and if you feel that item size is more, and you can further reduce it. So you can always have a check. So that's again a beauty of NumPy. When you run the codes on your productions, right? So you can actually give it as a check of item size. So item size should not be more than 1 or 2 and something like that. And then you can have it showed. You can have it run on the production. So that's again a very very good functionality available here. So technically now empty zeros and ones. Okay, so empty zeros and ones, they are almost identical. So they are more like we are creating a data, we are creating an array with either an empty data, or we are creating a data, creating an array with all the zeros, and we are creating a data, creating an array with all the ones. So that's what my empty zeros and ones means basically. Okay, so they have exactly same amount or same arguments available: shape, data type, and order. So shape is nothing but the shape I want the output array to be of, the shape of my output array. the data type of my elements, and the order. So order, you know, the C, F, and K. So K is random. By default, it takes row. So C is nothing but again row data type. F is nothing but my column major, right? So do not forget that. C is my row major. F is my column major, right? So here I'm creating an empty array of 3, 2. Do not get confused by these values. So even it is empty, it is giving you some values here, 1, 4, 2, 5, 3, 3. It's a garbage value. Okay. So whenever we create an empty data frame, right? So whenever you look at that, you're always going to get some value, and that's going to be a garbage value. But again, technically, it is not holding up any information here. It's a garbage value. So you're going to use this X for any type of your alterations. You can store another values on top of that. So that's totally possible. Cool. So let's creating an empty array for you. Likewise, zeros. So it creates all zeros. So it will create an array of all the zero values. And ones means it will create the array of same data type, whatever data and dimension I want, shape, for all the ones. Okay. So that's what your zeros, ones, and t's are more like. Cool. Another good function available is as array. So now here as array is like you're converting something which is already existing. So like you have as string, as list. So there are a lot of functionalities available in also base Pythons, right? So likewise, as array is nothing but you are converting the existing Python sequence into the n-dimensional array, right? So whatever which is existing, for example, now here you can see this X is 1, 2, 3, which is list, right? So now I'm converting this list into an array. So for this, I'm going to call the function as array. So I'm going to call as array for any existing sequence in Python, and I want to convert that existing sequence into an n-dimensional array. So that's where my as array has been called as. Again, as array is not only limited to my one-dimensional data. I can also have a list of lists, right? So this list of lists is nothing but my again a two-dimensional data for my array, right? So I can have that. So if I pass this n dimension, I can have 2, and if I pass the shape, so it's going to be 3 cross 2. Right, so I have 3 elements, and each of the 3 elements has 2 sub-elements in it. Right? So that's the shape is 3 cross 2. Right. So again, as array is used basically to convert the existing sequence into an array object. So that's how this is, right. Also, I can pass a tuple element on top of this by default. So tuple also So I have 3 information. So I'm passing tuple of 3 elements. So now I'm converting this into array. So this gives me the by default array element 1, 2, 3. But here the interesting thing, you can see this. So now here, did you notice? So I'm passing the list of lists, but all of these individual elements have 2 sub-elements, right? So 1, 2, 4, 5, 8, 9. But now here I'm passing the cross dimensions data. So 1, 2, 3, 3 dimension for my first element and 2 dimension for the second element. So 4, 5 for the second element, right? So now if you call as array on top of this, yes, it is able to convert this into an array object. It has done that. So now it has again 2 elements, 1, 2, 3 as one element and 4, 5 as the second element. But if you see the endim in the shape, now can you see this? In the dimension, it is showing me 1. Okay, it is not showing me 2. And I'll tell you why. So it is now showing me as 1 dimension data. And the second is it is showing me in the shape as 2, comma, nothing. So it is not giving me 2 or 3, whatever it is, right? So now what happens generally here is, so it is not able to identify the individual complexities here. So by default, it has to be the same data type. It has to be the same numbers if you want to call that, right? So it has identified this entire thing as one element. Okay, so this technically, which is not the thing, which is this is identifying it as one single element. The reason is the 4, 5, the 2 elements are common in place. So for example, 2 elements, but the third element is not common. So that is the reason why it is giving you 2 here as my common space. So I mean, it has anyway identified 2 individual elements, but it is not identifying the number of sub elements in each of my 2 elements, right? So the first has 3 and the second is 2. It is not able to identify that. It is giving you a blank. But it has identified that it has 2 sub elements in it. 2 elements, but how many sub elements of these elements it is not able to identify, right? So this is again very important, guys. Just look at this. So whenever we're going to create an n-dimension array, so the nth dimension, so all the dimensions should have exact internal dimensions also. So that is also very much important to create that. Cool. So that's again good. So again, I have a good function available from iter. So iter is nothing but I'm creating, so as array is nothing but as array is converting my existing sequence into an array object, right? So that's a plain simple calling of my function on top of my sequence. But from iter is nothing but it's creating an array object from an iterable object. So iterable kya hota hai? Sequence. Is like a again it's something in a loop, right? So you're running something in a loop. So something which is happening on an iteration based, right? So from the iterable object, you can also create a list. So basically, you can keep on appending each element from the iteration into an array element. So that's the front up. So from iter is like you're converting an iterable object into an array. So that's plain simple as that. Okay. So how it takes, it has three arguments again, iterable object. So it's like an iterable object to be passed. So data type and again the count. So count basically by default how many elements you want to read from the that particular iteration object. You want to read only the top 1, top 10, 100. So by default is -1, meaning it will take all the elements from the iteration. So you can also define the number of elements you want, right? So I've just created a range, nothing but an iterable object. So if I'm going to do range, so it has elements from range of 0 to 10. So basically 0 to 9, 0, 1, 2, 3, 4 till 9. That's what the element would be here, right? And then I'm using the iter keyword. So iter again, internal object here. So I'm just passing it here. So this it is nothing but my iterable object. So this you can see this range iterator object, right? So range iterator object. Now this iterator object I'm passing it on top of my from iter and this printing it. So now this array is now able to identify all elements from my array object, right? So if I pass say 5 here, so now okay, I don't think I can pass this here right now for this. Anyway, so let's stick to this. So now it is able to identify this iter object, nothing but my iterable part. So this is my iterator. So this is nothing but my range iterator here, and it has elements from 0 to 9, which I've created here from the range object, right? So nothing but, so as array and from iter is like again an object, again a functionality available to create your array from the available information data which I have, right? Arrange is again another very good function available. So most frequently used. So arrange is nothing but you are arranging some sort of available data into a ND array. So array is like you're arranging the data into evenly spaced information. Okay, so now there has to be some even spaces. There has to be a start, there has to be a stop, and there has to be a step, like the gap between each of my individual elements. So I have this much of flexibility. So I can create the ND array based on the start and the end value and the exact shape, exact spacing between each of the elements. So for example, np.arrange 545. What does it mean? So I'm going to start with 5. So the first element of my array should be 5. Technically it should end at 40, but each of the elements between 5 to 40 should be evenly spaced by 5 characters. So 5. The difference between my first and the second element, likewise the second and the third element, and then the third and the rest all, respectively with 1 step each, it has to be 5. So what it says, starting with 5, 10, 15, 35, and likewise it is taking up. Cool. So you are arranging the data based on my information given here. I can give anything. So for example, so I can give say 2, and I can say 15, and I'm going to give a space of say 3, for example. So now I have the similar information here. So I can get 2 plus 3 5, 5 plus 3 8, 8 plus 3 11, 11 plus 3 14, 14 plus 3 17, 17. So but I have to stop at 15. So maximum should be 14. Cool. So that's how things are, right? So that's how arrange works. So again, another good two functions, line space and log space. Very, I would say line space is again very frequently used. So arrange and line space, they are again, I would say synonyms. I would say almost similar functions available here. So line space is nothing but you are here in this information, you are also passing the step, right? So what would be the exact a difference between a one and the first and the second variable, second element, right? But in the line space, instead of giving this exact step, right, I'm telling that between this start and the stop, I want say how many number of elements I want. If I say I want 10 elements between 2 and 15, so by default it will internally do the calculation and it will see what step size it has to take so that it can accommodate 10 elements between 2 and 15 of evenly spaced size. So that calculation will happen internally. So in arrange, I'm specifying the step, the differences, the gap between my two elements. But in line space, we are saying how many elements I want between the stop and the start, right? Start and the stop. And the calculation of that step, the difference will happen internally. So that's the only difference between arrange and line space. Okay. So in line space, we have the elements का start and stop तो by default होगा ही. Num means how many evenly spaced samples it has to be it has to generate, right? So default is 50. Again, remember this, default is 50. So if you don't give anything, it will by default give you 50 elements between start and stop. Okay. It could now, if there is a, it definitely it will go in decimals also. So by default, right? Right. So again, we have three more important functionalities available here: endpoint, return step, and D type. So endpoint is nothing but if I'm giving it is true, the stop is the last value of my range. So if I'm giving endpoint is true, that means that stop, whatever stop value you're going to give, it's gonna take that also in place. So the last element would be the stop element, and then the evenly spaced sub element between those. Also, red step is nothing but return step. So the calculated information of my the gap, right, between my two elements. So whatever step got calculated internally, it will also return that step value once you run that. So that's how it is. So now let's see this. So I'm going to pass endpoint as false. So basically it should not consider 20. So the end element is not 20, it's 18. So between 10 and 20, I wanted 5 elements. So it has done that. So now 10, 12, 14, 16, 18. So by default, it has omitted 20 because I've given endpoint as false, right? Also, red step means returning the step size. So you can see this between 10 and 20, I wanted 5 elements. So it started from 10, then 12.5, 15, 17.5, and 20. And it is in the elements, comma, so it has 2.5. So the step size is 2.5. So you can see you're returning the step size also from this. Cool. So that's the line space for you. Very interesting function, but that's a very I would say raw difference between your arrange and line space. Okay. Log space is also similar, guys. So again, it's a similar objective here. So we are trying to have the number of elements available between my start and the stop. Okay. And but here is this like how many here instead of having the start and the stop is like this. The sequence is basically a base of my start. Okay. So it's like a logarithmic base of my value, right? I can also specify the base value. So default is 10. I can give the exact, I can take a base of 2 or whatever I want. So right, so default is 10 by default. So again here I can have that number of sequences between the logarithmic base of that value. So that's one thing which I have to take care of. Cool. So basically what I mean, so log base of 10 and the log base of 2, log base 10 of 1, log of 1, and the log of 2. Between this I want 10 individual elements. So that's what it is. That's what does it mean. Cool. Any questions, guys? Okay. If nothing, then we can proceed. So we also talked about indexing and slicing of my arrays, right? So now I have my arrays in place. So definitely I want to index the individual elements. So what element is present where and how I can get a particular element of my interest, right? So very, very important point. So I want to index a particular element. I don't want in the entire array. So I want the indexing to be done. And also that index element has to be sliced out, right? So it has to be taken out for my further computation. So indexing and slicing, very important I would say feature of any of the data types. So again here in arrays also there are different ways where you can index and slice your arrays, right? So we'll talk about that. So just by this we anyway know slice is the internal operator available in Python. So slice is also available. So in this slice it takes 3 arguments. Again the same thing, start, stop, and step. So you know this, right? So starting point, ending point, and step means what will be the difference between the two elements. So that's the start, stop, step. So if I'm going to do that, so this is my array. So like 0, 1, I've given the arrange, right? So arranging is giving you from it's like more of a range for me. So 0 to 9. So this is what I want, right? This is what my array is. So I'm slicing between 2 to 7. So like 2. So 2 to 7 gives me this. So between 2 till this is my interest. but this is my interest area between defining my start and the stop, but I want step size of 2. So the difference should be 2. So the first element will be 2, 2 plus 2, 4, 4 plus 2, 6. If I do 6 plus 2, it will become 8, but the endpoint is 7, so the 8 would not be considered. So I'll be having 2, 4, and 6. That's the slice operator does. So instead of using a slice operator, inbuilt operator, we can also pass it form of a square bracket. So in the square brackets, like the way we are doing in lists also, right? So remember that. That is also possible in array. So we can have this similar kind of indexing possible: start, stop, and step. Standard range, so the way we are giving it. So all the available functions like this, like a single element, like defining the single element like this, or starting from a range. So I can also give a range here. So starting from 2, all the elements. So after 2, I want all the elements. So I've given this. So 2 के बाद सारे elements चाहिए I've given that. So likewise 2 to 5. So I have 2 through 2, 3, 4 here. So I have all the same functionalities which is part of my array ka indexing, right? So still applicable lists ka indexing. So same on all applicable on my arrays as well. Here, so that's the one thing. Now coming about my multi-dimension indexing. So that's a very simple indexing, right? So here you're not doing anything. So you're just simply doing more of the same indexings, right? So more of range type of indexing. But now let's come about indexing in form of my multi-dimension data, right? So I have to specify what exactly row, what exactly column I want to specify. So like think of more of an row and column kind of a data, right? So I'll talk about that, what I mean from that. Cool. But the only important thing to understand here is in form of arrays. So indexing is also done using ellipses. So very important concept. So the arrays indexing is also done using ellipses. Ellipses क्या होता है? Ellipsis is nothing but 3 dots. So 3 continuous dots. We are seeing this here is what called as ellipsis. Okay, so that's the standard way of indexing available in my arrays also. So we're gonna do it through ellipsis. So ellipsis में क्या होता है? So ellipsis is nothing but it gives you it's a meaning of all. So if I'm giving ellipsis, that means all. So just by default is a conversion. You can see this ellipsis is nothing but all. So if I'm doing this a square bracket ellipsis, that means that all the elements of a has to be given here. So my a is my multi-dimension data 1, 2, 3, 3, 4, 5, 4, 5, 6. So you see things. So if I'm gonna run it like this. Just a minute. So if I'm gonna find out a ka ellipsis, so that means that I'll be getting all the elements here. Okay, but what now here ellipsis means also I can use it pass of my rows and columns. So rows and columns क्या है पहले इसको समझते हैं. So my all the data is form of this, right? So it's more of a internal small data frame kind of a thing. I'm just from a visualization perspective I'm telling you. So the first column has first row has 1, 2, 3. Second is 3, 4, 5. The third row is 4, 5, 6, right? Similarly, the first column is 1, 3, and 4. The second column is 2, 4, and 5. The third column is 3, 5, and 6. If you just try to visualize it from a data frame perspective, okay? This is why I'm telling you this. So in the ellipsis, in the indexing part, we have what? The rows and the columns are structure, right? I can also pass the rows and the columns which I want, right? So rows and columns को कैसे specify करते हो? Using a comma, right? So the comma here. So now, for example, suppose I'm doing this and giving you some values here. For example, so now this is the first part is my rows, the second part is my columns, right? So I'm giving ellipsis in my rows. So that means that I want all the rows to be considered. Okay, so that's my first thing. So I'm saying that I want all the rows to be considered, but in the columns I only want the 0th column. So 0 Python में indexing कैसे start होती है? 0 से start होती है. 0 means the first column. So first column क्या है? 1, 3 and 4. So हर एक row का I want the first element. So by this I mean the output should be 1, 3 and 4. Any doubt guys in this? You see this? The output is 1, 3 and 4. So now just the vice versa of this. What if I do like this? So now what I'm saying, now I want only the first row to be considered. So I'm saying that only the first row to be considered, okay? But in the column I want all the columns. So basically first row ka all the columns. So the output should be what? 1, 2 and 3. So here sorry, my bad. So first means the second, so indexing started from the second index, right? So I have 3, 4 and 5. My bad, I'm really sorry. Right, so that's what I have. So I have 3, 4 and 5 here, right? So that's what indexing works. So I can also give, suppose I give say like this. So instead of this I give 0, comma, range, comma, 1. So I'm saying that the 0th and the first row, but all the columns to be considered. So here the output would be what? The output would be again by 1, 2 and 3. So in the form of my arrays. So likewise I can just do n number of computations here. So you can just keep on trying. So here I have given, for example, this. So now just look at this. So here what I'm doing, I want from the first row till the last row. So first row is this 3, 4, 5, right? And I want 3, 4, 5 and 4, 5, 6 to be considered, and I want only the second column. That means the third index ka column. So 5 and the sixth element. So this is your output, 5 and 6. Cool. So ellipsis is again very interesting concept here in arrays. So ellipsis is more towards your higher end indexing. So ellipsis by default means all. Okay, so 3 dots means all. So if it is given in rows, before the comma, it's like all rows, or if it's like after the comma, it's like all columns. So that's the only difference, and then you can play around with your ranges and whatever you want. Right? So that's your ellipsis for you. Cool. Any doubts, guys? Cool. So that's one way of indexing your arrays. So basically through ellipsis. The second interesting way we have is through an integers. So I can also specify. So here it is basically doing all rows or columns. But again, I can specify I only want the second row ka first column, and then the second element should be first row ka third column. So exactly pinpointing what all elements I want in my data. Okay. So that is also quite possible. So how it can be done? Let me show it to you. So now, for example, I have created this data frame. They created this in array. So again, a two-dimensional array. So in this 2-dimension, I have 3 sub-elements, and the 3 sub-elements has two elements each. Right? कोई नहीं यार, जो देखेगा बाद में रिकॉर्डिंग भी देख सकते हैं. So totally fine. अभी इसको फिनिश कर लेते हैं थोड़ी देर, and then we'll stop anyway. Cool. So here integer indexing में क्या है guys? So आप देख सकते हो यहाँ पे I have a 2-dimensional का data. So I have created 1, 2, 3, 4 and 5, 6, right? But on top of this, I'm specifying what all elements I want, right? So here you can see this, I'm specifying the indexes. So I'm making the indexing ka concept, indexing, individual indexing what I want, and from this, how I want to index it. So for example, I've created the xth element and the yth element. Okay. So how it takes? So let's look at that. So the first element I want the index of 2 cross 0. So the x value should be 2. I mean the row value should be 2 and the y value should be 0. So what is at 2 and 0? So we have 2 and 0 mein kya hai? The second means the third row, which is this 5 and 6, and the 0th element, which is my 5. So the output for this 2 and 0 is what? 5. Cool. So this coming as like this. Now for here and again the second element is 2 from the row, and the from column I have 1. So the second row kya hai? 5 and 6, and the one index ka value kya hai? 6. So I have the value will be 6 here. Cool. So this my bad. Just a minute, I think I can go into markdown. Cool. So 2-1 में क्या आ रहा है guys? 2-1 में मेरे पास आ रहा है 5 and 6 में से 6. Correct? And then I have 1, 1. So 1, 1 में क्या है मेरे पास? The first row, which is this 3 and 4, and the first element, which is 4. Right? So this is what I have. So this is the output. So output should be, if I do this indexing, so I'm specifying each individual element of my array. And guys, if you have any confusion in understanding this, do let me know. It's a bit tricky, but you should be knowing this. You have already covered किया हुआ है. If anybody has any doubt, do let me know please. So अब इसका output देखो. हमने यहाँ पे क्या decode किया था? 5, 6 and 4. Exactly the output is 5, 6 and 4. So I can specify exactly what individual element would be comprising in my output array. Cool. So that's how we take care of, guys. So if again anybody has any questions in this, do let me know. Cool. This is a very again interesting way of indexing on arrays. So that's how we take care of. Again a very interesting thing. So you can also just keep on doing it. So rows maybe we can have a multi-dimension index. So rows also is specifying individual indexing. So now look at this. Now for example, let me just print it for you once and then show it to you. Okay. So now I've created again another array. So I have this 0. I have again a 2-dimension array, but I have the shape here is 4 cross 3, right? So I have 4 sub elements and 3 internal elements of each of my sub elements, right? So that's the shape of my data is. Now I'm indexing based on rows and columns, and the row maybe so here you can see this. It's a 1 dimension ka indexing I'm doing, right? So indexing I'm only giving 1 dimension of my array, right? So 1 dimension ka data. But now in indexing also I'm specifying 2 dimensions. So that is also quite possible. So in indexing, in fact in indexing also I can do multi-dimension indexing. So that is also possible. So ab isme kya hai? So in the row I'm giving 0, 0 and 3, 3, and in the columns I'm giving 0, 2 and 0, 2. इसका मतलब क्या है? Now look at this. So that means that what all columns I want. So here technically the output should be a 2-dimension data. Output cannot be a 1-dimension data. Output has to be 2-dimension data because I'm specifying it has to be 2-dimension data. And उसके 2-dimension का sub-dimension क्या होगा? 2. Because each of the sub-dimension has 2 elements, right? So इसका एक element बनेगा and the second is this element. So how exactly this would be done? So the first sub element would be this 0 from X and this 0 for this 0 from row and this 0 from column. So this 0, 0 is here and 0, 0 में क्या है आपका यहाँ पे? 0 is 0th row, which is my 0, 1, 2, and 0th column means the first column. So again the value is 0. Cool. Now the second element is 0 cross 2. So 0th row ka second index ka column. So 0th row is 0, 1, 2 and the second index is 2, right? So this value is 2. Now this is my first output. So the array would be like this, 0, 2. This is my first array. Now the second, the second element of my sub array would be 3 cross 0. So the first X would be 3 and the Y would be 0. So the third index is what? 0, 1, 2 and the third index. This is my third index of my row. So 9, 10 and 11 and I'm giving the 0th column. So this is my 9. The value is 9 here, right? So this is my 9 coming down here and the 3 cross 2 likewise is third row, the third index, which is my fourth row, and the second index means the third column. So this is my 11 value. So I have my value here as 11. So I'm gonna the output array would be 9, 11. Cool. So this is what I'm expecting it from this indexing. So now let's look at this, how Y looks like. So I have Y here. You see this? So I have 2 sub elements. So this is a multi-dimensional, is a 2-dimensional arrays, 2-dimensional indexed array. So I have the output as like 0, 2 and 9, 11. And I have pinpointed, I have actually used the integer indexing based on my index ka position for identifying each of the individual elements of my array. Right? So that's something which is again very much interesting. Cool. Guys, इसमें कोई doubt है तो please let me know. ये थोड़ा सा tricky है to understand the integer indexing. So but again, arrays की indexing दो तरीके से majorly होती है. The first is through ellipsis, जो हमने सीखा. Ellipsis is nothing but my all. So ellipsis is directly converted to all. आप ellipsis को all से consider कर सकते हो. And integer indexing में जहाँ पर आप हर एक elements को individually specify कर रहे हो कि what is that element, right? So and specify कैसे कर रहे हो आप? you are doing using your np.array ka functionalities, and here I'm specifying each of the elements. So x and y, so rows and columns ke perspective mein, I'm specifying what all elements I want from the input array. Cool. So that's how my things are. So again, that's my another way. So last way is Boolean slicing. So मैंने बोला filters. So Boolean slicing क्या होता है यार? Again, जैसे आपने data frame में भी देखा होगा. So you are specifying if you want to filter out any column. So you're going to give, right. So if my I want to know all the rows where the salary is more than 10,000, for example, right. So this is again another way. So I'm doing a filtration, row ka filtration. Again, it's kind of a slicing only, right? But giving some condition to filter out that information, right? Cool. So that's how it is, and that's what we have finalized using. So so now I have this information here, for example, right? So this is my array 0 to till 11, and I'm giving this. I only want the x where the x's is greater than 5, for example, right? So all the elements of my arrays where the values is greater than 5 will be filtered out. So that's something about 6, 7, 8, 9, 10, 11. And by default, it will return a 1D array. So whatsoever your dimensionality of your input array, the output from the Boolean filter will always be a single dimension array. So that's one thing which we can think of. Cool, simple है, इसमें कुछ ज़्यादा फंडा नहीं है. मतलब ये तो हमने already basic चीज़ें देख ही रखी है, तो there is no major issues in that. Cool guys, any questions? Thank you so much, Vandana, for for good words. I hope you are still there with us. But anything guys, any other questions for anyone? I hope I'm pretty much clear for the things. Cool. So again, the next very interesting I would say property of array is broadcasting. So broadcasting क्या होता है? So now, for example, you have two different arrays with you, right? So like A and B, and if they are of the same dimensions, तो उसमें कोई issue नहीं है. You can do the operations on top of that very easily. So आप sum कर सकते हो, multiply कर सकते हो, divide कर सकते हो, subtract कर सकते हो. So all the mathematical computation is slightly easier when the dimensions of my two arrays are similar, right? So that's technically that's what I'm saying. So if my dimensions are similar, so the mathematical computations become easier on top of my NumPy, right? But now in some cases when my I would say the dimensions are not same, right? So when the dimensions are not same, then in that sense it becomes a little trickier, right? So then I would say that the broadcasting comes into picture. So here, for example, I'll show it to you. So for example, suppose I have two arrays A and B. So I have, say, it's of the same dimensions, right? So 1, 2, 3, 4, and then I have another set of arrays here. So just if I'm going to do the multiplication, for example, A cross B. So इसमें क्या होगा? 1 will get multiplied by 10, 2 will get multiplied by 20, 3 will get multiplied by 30, right? So likewise. So each of the elements are getting multiplied by respective position ka element, right? So that's how easy it is. So it's the same dimensions, it's not a problem. But now when we have different dimensions ka data, so for example here in this, right? So you are seeing this 1, 2, 3, 4 is a smaller array, so it's a 1D array. But now the second array is a 2D array. So in 2D array I have two elements here. So 10, 20, 30, 40, and I have 100 and till 400, right? So now what happens? If I'm going to do a multiplication on top of this, so what happens? The smaller dimension array gets broadcasted into the higher dimension array. So what does it mean? So here the smaller dimension array is 1, 2, 3, 4, right? So 1, 2, 3, 4 will get broadcasted. So this 1, 2, 3, 4 will get first computed by the first element, and then this smaller array will get computed on the second element of my larger array. So that's like the smaller element gets broadcasted to the larger array. So that's how it is. So now look at this. So what A cross B, so 1, 2, 3, 4 will get multiplied by 10, 20, 30, 40. And again this 1, 2, 3, 4 will get multiplied by the second element of my array. So that's how my output will look like. So that's the broadcasting ka funda. Again, a very interesting topic, guys. So this is I would say one of the very interesting properties. So when actually you will be doing some of your data analysis, right? So you might be using this internally, so for your calculation purpose and all that. So because this is how broadcasting works. So if you don't know, it'll be a fluke for you that whatever you're getting. But technically this is a very good property of an array. So it gets the broadcasting happens from the small array to the larger array. Cool. So likewise, again, it's not only on multiplication, so we can do on addition and all that. So likewise, you can see this. I have this one smaller array, so bigger array, and then I have this smaller array, so 1, 2, 3. So I have here, this is my smaller array, 1, 2, 3. I have the bigger array, this bigger array, two-dimensional array here, and doing the sum. So like what happens is 1, 2, 3 will get added to my first element. So this the first 0, 0, 0. So the first output is 1, 2, 3. The second is 11, 12, 13. Likewise for all of the individual sub-elements of my array, the two-dimensional array, the smaller array is getting broadcasted and the computation is happening on top of that. Cool. So that's how these things are. Cool. Okay, so ND iter is again an interesting thing. So let's just maybe take one more property today and then maybe we can stop. So I think it's anyway too much for the day. So let's take this one and then we can stop for the day. Cool. So ND iter क्या है? Okay, so ND iter is again, so like we use the from iter, right? So from iter क्या था? वो एक sequence का object already existing. So you already have a iterator object, right? But and then on that iterator object, you're converting that iterator object into array, right? But ND iter is opposite. So ND iter is like you are iterating over an array. So for example, the for loop, right? So for loop क्या करता है? You are accessing the individual elements of my list or whatever dictionary you have, right? So you're iterating over my elements. But in arrays, if you want to iterate over your elements, how you gonna do that, right? So how you gonna iterate? So iterate over the internal elements of my array. So for that, instead of, so it's like an alternative to for loop of list or alternative of for loop to dictionary. So that's what we have a function called as ND iter. Okay, so ND iter is very important function, guys. I would say one of the key functionalities in arrays, right? So ND iter, so you have this array in front of you. So I've just created this. So 20, 25, 30, 35, 40, 45, 50, 55, right? So I've created this using np.arrange. So start, stop, and step. I've given this. I've reshaped it using 2 cross 4. So two elements, two elements, and each of the sub elements will be having 4 elements inside it. So that's what I've reshaped it to. So now np.nd iter. So I'm passing the reshaped array here, and also the very important thing is the order. Okay, in which order I want to iterate the data as. So I told you there are 3 types of ordering: C, F, and K. C is my row major, F is my column major, K is the random. Okay, so F I've given here, for example, is the column major, right? So what it does, 20, the first element would be 20, the second element would be 40. My first entire column would be iterated, then the second column. So then the third element is 25, the fourth element is 45. Now what will happen if I give C here? If I give C, so now you can see this. The first row is getting iterated over first. The elements are like the first element is 20, second is 25, third is 30, fourth is 45. So likewise, the elements are being iterated over, right? So the order is very important, guys. So always remember this, order is very important. Cool. So that's how things are being taken care of. Again, in this ND iter itself, we have certain another very good arguments available, right? So I'll just show it to you once. So okay, yeah, like for example, you can see this. So now what I've done is I've created the same ND iter element, right? So same array here, so 20 till 55. Now I have transposed this. Okay, so now this entire 2D array from the shape of 2 cross 4 has now been converted into the shape of 4 cross 2. So now can you see this? So now the rows has become columns somehow, and the columns has become rows. Okay, so look at from the data frame perspective. So now this 20 and 40 has become the one row, and 25, 45 likewise has become the second row. So the shape from the array from 2 cross 4 has now been converted into 4 cross 2. So 4 elements of 2 sub elements, right? Now the very interesting thing to see is, right, so technically आप देखो यहाँ पे क्या हो रहा है, अगर आप इस B कॉलम पे, so now can you see this? So I'm doing the nb dot nd iter on my B column, so which is my B array. So this is my transpose array, and I'm doing the C, which is my row ka major. So I'm seeing the data which is on top of this 20, 40, 25, 45, 30, 50, and then 35, 55. Now look at this. If I'm 2 over F, sorry, my bad. Okay, right. So so now F is nothing but my column major. So column major में आपको दिख रहा है यहाँ पे 20, 25, 30, 35, and then 40, 45, 50, 55. So I can have that functionality prepared on before doing the ND adder also. So I can call the transpose or whatever functionality I can do on top of that, and then we can do this. In fact, within this individual ND iter, I can, if I want to do some computation, for example, suppose I want to add say 20 pay plus 1, or I want to do 40 plus 1. So I want to add this entire element of my array with plus 1, for example, right? So some, it's just like not accessing, also doing some kind of modification on top of my array, right? So that modification is also slight possible. So in that, we have something called as two arguments available here. The first is OP flags. Okay, so OP flags is again one of the very interesting parameter available. So OP flags क्या होता है? By default is read. Okay, so by default is read. So it's read only mode पे रहता है. So ये OP, अगर आप ND iter करते हो, it's only just giving you the, it is accessing the element. It is not changing the, modifying the elements, right? So by default is read write. If you want to edit it, if you want to change, modify the content of my element, so you have to convert the read only mode to read write mode. Okay, so that read write mode is very important. So whenever you're iterating it, you're just passing an argument OP flags and then making it read write. Okay, so then you'll be able to change it. So now I'm using the ellipsis. So all the elements, so you can see this, right? So I'm giving this, all the elements of my x should be multiplied by 2 now. So you can see this. So internally it has 20, 25. So now all the elements are multiplied by 2. So without giving this OP flags, you will not be able to alter it. The modification is also possible on each of my elements, but you have to specify the OP flags in that. So operation flags. Cool. So that is pretty much which I wanted to cover. So OP flags is again one of the very good arguments available inside my iterable objects of arrays. So that is purely for my modification of my existing array. Cool. So I think with this, let's stop for the day. So we can cover the remaining, not that much of functions available. So I'll cover the remaining functions tomorrow. So we'll finish that. So I think till here we anyway covered till our last session. So that's where we left out in the last session. So that was the last thing. This is the last thing we covered in the last session, as far as I remember. So from tomorrow, for next maybe a day or two, I'll try to finish the entire existing functionalities and entire existing functions available under NumPy, and then I think you should be very much comfortable with that. Cool. Thank you so much, Vandana, again, and all the other people, Ajit, Harsha, for being our chat. So once again, thank you so much, guys. So with this, we're pretty much done. I'm going to give your evening back, and thank you so much for being patient. I understand sometimes concepts are a bit trickier to concentrate on, but yeah, I mean, those again are important once you're going for your problem solving sessions, right? So I always believe the concepts are more important. So when you go for the problem solving, so concepts are the base for everything, right? So, but again, thank you so much for being patient and listening to me. So with this, we're going to wind up. So we're going to see tomorrow again at 9 p.m. and I'm going to finish the other remaining NumPy sessions. I always will always welcome the questions from you. So if you have any questions, any doubts, to put up your things in the chat and we'll try to take that. But for now, definitely thank you so much and wish you a good night, and then see you tomorrow at 9 p.m. Thank you so much.